Another Dibs research video. Hello, fellow research nerds. How are we doing on this fine day? I want to go over a few things regarding the benchmarks that we're currently in. As you can see, I've just been came to visit my classroom for a little bit, and I want to take a little time to go over some of the benchmarks that were posted on Classroom and kind of what the expectations are, and then talk about what we're going to be doing this week. So, first and foremost, let's talk about the resume benchmark. So what I want to do is just kind of take a look briefly at a sample resume from last year that was really good. So this is Kira Fendikian's from last year, and I really like the clean layout of it. And I want to point out really a few things that I think are important. So first off, at the top, notice she's got her phone number, her email. Notice it's a personal email and not a school email. That's important. And she's got her address, which is just Pelham, New York. Please do not put your real address on there. Next, she starts it off with an education section, which I like. So she's going to talk about where she is. A big thing that she has here is class of 2025. So you can see it. Let's see if this works. Yeah, so you can see right here, it says class of 2025, and then she lists some important things like her AP honors courses, right? Some of the feedback that I gave her was actually to be a bit more specific right there. Would have loved to see, oh, I'm in AP stats. If you're taking AP stats, that's something that needs to be kind of front and center on your resume. So some other things that she got, right? Great, amazing. Then another full section dedicated entirely to science research. So this is something all of you should have. So notice how she has focus on fetal medicine, right? Presentation on germline genomes of monozygotic twins. What is she talking about there? Did she do something that you guys didn't do? No, she's talking about the presentation she gave at our symposium. So I want you guys to be a little more specific than she was there, right? So say like gave a presentation on blank at the Pelham Memorial High School Science Symposium. Then I would have liked to see her start with a verb here in all of these. Right? Gave a presentation or wrote a comprehensive review of literature focused on the detection of twin-twin transfusion syndrome. You guys all wrote a review of literature. That should be on there. Your Shark Tank idea, if it's a great idea, should be on there. Do not write Shark Tank. No one knows what that is outside of Pelham science research, right? So make sure that you guys, just write what you did. Designed a brilliant method for blankety blankety blank, whatever you guys did. She also did a camp, right? So we have a Boston University camp here that she went to over the summer, and she put that in under science research. All right, sorry, had a quick little technical issue, but now let's look at the bottom part of her resume. She's got a section called work experience. This I really like for things like she has babysitting on there, any jobs that you have, any summer jobs that you did, anything that really shows that you're responsible, right? It might not be related to science, but we want to put it in there to show that we're a responsible, high-achieving kid. That we could throw into like a work experience section, and then below that, extracurricular activities and some unique things like that. This resume is kind of missing some stuff that you generally see on like resumes that you put out to jobs. And this is kind of because we're not reaching out for a job, and we're not technically reaching out for an internship either. We're reaching out for more of like a partnership. So these are the kind of things that we want to have on our resume, and this is a nice clean layout. It fits almost perfectly on one page. And it really looks awesome. One of the bits of feedback that I kind of gave her is I would like to see all of these bullet points here. So, how we have this here, these bullet points indented a little bit from the Pelham Memorial High School part on top that's up here. I would have liked to see that just to help break it up a little bit. And I also like to see when things on resumes start with a verb. This is like a classic bit of resume advice, is to make sure that all of the things on your resume start with a verb. So
Now what I want to do is talk a little bit about your mentor search.
All right, now that we've talked about resumes, I do want to talk about finding an internship and the benchmark that you guys have due on Friday. So first and foremost, I want to remind you guys that science research is a subject that you get out of it what you put into it. So you guys are all going to be searching for internships and, looking for people to work with you, and they may or may not want to see your resume. I mean, they probably won't want to see your resume. I mean, what's on the resume of a 15-year-old kid? Maybe not that much. So what we do, though, want to have is a resume in place that's excellent. So if a potential mentor goes, well, why don't you send me your resume real quick to give to my boss so we could get the process started in getting you into our lab? You need to have a good professional resume ready to go. So if you dog it on this benchmark, whatever, and then all of a sudden that happens, and then you come in, Mr. DeBello, I need to put together a resume real quick to email this mentor. I'm going to be like, we did this already. And I'm not going to be able to spend the time with you to really get a good resume going. So you want to make sure that you have a strong resume ready to go. Now let's talk about the benchmark that's due on Friday, finding 5 potential mentors that we could email, or call, or reach out to in some way, shape, or form. So you're going to do this in 3 main ways. The first of which you guys have already done a ton of legwork on, whether you realize it or not, but the authors of your articles. The authors of your articles are incredible scientists that have done work in a field that you're interested in and you've already read and are pretty knowledgeable about. So authors to your articles are great ways to find potential internships and potential mentors. If you're planning on going into a different field over the summer, which you are more than welcome to, you do not have to stick with the topic that you've been going into. If you want to go into a new field, start reading some literature on that field. See what's going on out there and see who's currently publishing stuff. So look at those current articles, things being published in 2022, 2023. The second thing that you can do to find a mentor is look at local research institutions. Look up Weill Cornell, Columbia, NYU, Memorial Sloan Kettering. If that's the kind of field you want to go into, that medical field, there's tons of stuff around here locally. Look them up, look at their research divisions, do a little stalking on their website, find some LinkedIn pages, and find some people that are doing research, find their publications, and read what they're all about. So those are really the 2 main ways of finding people, and both of them end with reading the literature that person has published and becoming a little bit familiar about what they're currently working on. And then the third way is talking to people in your family. Now, some of you have parents that are already research scientists. That's amazing. However, those of you that don't be discouraged. You'd be surprised who your parents know, who your aunts and uncles know. There's probably tons of people in your life that know people that conduct science research, and you would have no clue. So talk about it with your family. I'll remind you again before Thanksgiving, but before Thanksgiving, my homework assignment for Thanksgiving break is to talk about science research with your family at the Thanksgiving table if you celebrate Thanksgiving. You're going to have a lot of your family there, hopefully, and you'll be able to, just talk about it. And you never know when your uncle might be like, well, I knew this guy Kevin back in college. He was doing some particle physics stuff like you were thinking of doing. Maybe I give him a call, see what we can do. He might be able to help you out. You never know who people know. So those are really the 3 ways of reaching out and finding a mentor. And I kind of want you to go through this. Don't email anyone yet, but put together this list of 5 people. For this list, you should have their name. You should have contact info of some sort, whether it be email, phone call, whatever that is. And then you should have their a little bit of background on them. What are they currently researching, or what have they researched recently? where are they located? Like that sort of thing. So when I ask you about them, like when I come back, we're going to have sit-down meetings and talk about who you're going to be potentially reaching out to first when I come back from my paternity leave. And in that one-on-one convo, I'm going to be like, all right, who's this person at the top of your list? Why are they at the top of your list? Talk to me about them. You need to be able to talk about them and give some insight about what they've done. So make sure that you have that there, but otherwise it's kind of free form. However you want to put this together, whether it be on a Google Doc, Google Sheets, whatever's going to work for you organizationally to submit on Google Classroom by Friday. Now that we're done talking about mentors and stuff and our Friday benchmark, we're going to jump into some statistics and a little bit of the classwork that you're going to be doing in class. So let's get to it. All right, ladies and gentlemen, it's time to do some science. Our ultimate goal this year is to create a research plan based on the review of literature that you've written. That gap in research that you've highlighted, our goal here is to design an experiment, talk about how we're going to analyze the data in order to answer that question, and then we're going to present this in June. So what we need to do first and foremost, before we get into writing the rest of that research plan, is talk a little bit about statistical analysis. And what I want to do, and my goal, is to give you guys a little bit of a toolbox in terms of some basic statistical analysis tools that we use in science research at this high school level, and how to do them so you're able to, one, create this research plan, but then two, during your internships over the summer, you'll be able to jump right into that data analysis on your own. So the key there was on your own. So what I want you to do is create a document in your Google Drive. That document should be called Statistics with DeBello. I want you to save that in your Google Drive with that name, because what will inevitably happen, my friends, is you will find a mentor, you'll work with them, and your mentor will then send you a data set if you are in a virtual internship, and then they're going to be like, well, I want you to do some analysis on this and get back to me, and you're going to be like, what? So then you're going to come in, you're going to be like, Mr. DeBello, my mentor sent me this, I don't know what to do, right? Or more realistically, you're going to go, Mr. Beltakis, my mentor sent me this. Beltakis is going to be like, you need to talk to DeBello, and then you're going to come over to me. And I'm going to be like, hey, where's your Statistics with DeBello Google Doc? If you do not have that Google Doc, I will not help you, because what I want you to do is give yourself, be kind to future you, and give yourself a set of instructions here to the two things that we're going to do to analyze data. The first is find a relationship between variables. And the second is to find a difference between groups. So let's talk about the difference between a group and a variable real quick. A variable is anything that varies. For example, temperature is a great variable. It varies anywhere from negative whatever, depending on what unit you're on, all the way up to infinity, right? Where 0 degrees Celsius is the freezing temperature of water, 100 degrees Celsius is the boiling temperature of water, and it lands anywhere in between or beyond that. So it is a variable, something that varies. Another example could be your test scores. They vary anywhere between 0 and 100, and they have an average somewhere in there, right? Another example, and this is more like towards the psychology end of things, like on a scale of 1 to 5, how depressed do you feel, right? Those types of questions turn a feeling into a variable, right? And that's going to variable anywhere between 1 and 5, and people on average are going to be stressed somewhere in between those things. So those are variables, things that we measure on a scale. So an example here, if we're looking to find the relationship between variables, maybe we say, hey, is there a relationship between a student's GPA, which is a variable thing, and how many books they read a year, which is another variable thing, right? Is there a relationship between those two? That is the first thing that we're going to jump into. An example of a difference between groups might be, hey, our GPAs, that's a variable, but is there a difference in GPA between boys and girls, right? So Is there a difference between male GPAs and female GPAs? And is it a significant difference? These are the two different ways we can analyze data. And what we're going to do is start with the first one, which is relationship between variables. So let's jump into that with a sample spreadsheet here. And what's cool about it is this spreadsheet is down in the description below. Make sure you open it up so you can follow along as we go. And then also on your computer, you should have your statistics with Debello document open, and you should be making instructions for yourself. So in this sample data, let's make it a little bigger here. In our sample data here, we have two variables. We have enjoyment of bananas on a scale of 1 to 5, and then we have number of bananas eaten. So these are two things that vary. So if we want to analyze this data and see if there's a relationship, it seems like there is, right? We see, it looks like the numbers get higher the more someone enjoys bananas, but is it really? Or is it up to random chance? And that's always kind of what we're fighting as scientists. Is this relationship that we see just random? Or can we concretely say that these two things are related? So to do that, we're going to use Google Sheets to do this. We're going to highlight all of our data, including the titles at the top. So you're going to put the variable name at the top and highlight all of the data below, and you're going to highlight the two that you're looking to see a relationship between. As they're copying this down, right? Nice job. So then you're going to insert a chart. So we can do that by clicking on the little chart icon here in Google Sheets, or by going to the insert pull down and selecting chart. So once we have that, I have this beautiful graph that pops up. Looks glorious. You love to see it. So does it look like there's a relationship between the two? I think so. In fact, some might say it looks linear. All right, now that we've kind of seen what the data looks like, right, let's go in and make sure Google Sheets is not falsely representing this data. So these check marks at the bottom are very important. Well, actually, first and foremost, select a scatter chart. This is the only chart that will do science for you. Every other thing in Google Sheets is more like a way to make pretty pictures. You're going to do the statistics somewhere else and then use Google Sheets to make a pretty picture. But a scatter plot is unique because it can actually do some science for us and help us in the analysis process. So we select a scatter chart here, and then we go to these 4 boxes down here, right? Switch rows and columns. That was an absolute mistake to press, so let's undo that, right? Make sure that is unchecked, right? Use row 1 as headers. This should be checked because our row 1, our top row up here, was indeed headers. Then use column A as labels. This is one that Google doesn't automatically get right a lot of the time. If it's unchecked and you see red dots and blue dots, that's what's going on here. So make sure you use column A as labels is the first one. And what that really means is use column A as a variable, not as a label, which is, I don't know, Google being not really a scientific tool, but there it is. So you're going to use column A as labels. You're going to make sure that's checked, and we have a nice graph with just one color on it. All right, so after we do that, we can go to the customize section, and in here we could change the style of a lot of things, like the background color, border, so many different things. There's some fonts. We could go with a little Roboto font. That's not different at all. Maybe a little Garamond, for those of you that don't know. That is the font of Harry Potter, its official publication. So anyways, you could beautify this thing all you want, make it look really pretty. But I want to draw your attention to one more thing before we go on. What the axes labels are. So we can see the y-axis here is labeled as bananas eaten. So that means the y-axis was our second column here. And the x-axis, enjoyment of bananas, was our first column. So when you guys are putting your data into Google Sheets to make a chart, make sure that the thing you want on the x-axis, your independent variable, is the first column. And then the dependent variable, the thing that's going to depend on the first one, is on your y-axis. Okay? So the x-axis will always be the first column, followed by the y-axis. Okay? So now, ladies and gentlemen, after beautifying our graph and making sure everything looks great, it's time to get serious. Get it? That's right. We're going to click on series. Okay? And this is where we can actually do some statistics. So if we're looking for a relationship between two things, we are going to click trend line. So a trend line should show us how these things are related. Specifically, a linear trend line tells us if something is directly related to something else. So, does this look like these two things are directly related? Do these points fall on this line? For the most part, it looks okay. If only there was a numerical way to see how well this line fits the data points that are there. And that is something called R-squared. So when we check this box in Google Sheets that says show R-squared, it brings us a value up here on our spreadsheet. R-squared for this equals 0.986. So what does that mean? I'm going to oversimplify this here for you guys. We're doing science, and I want the focus to be on the science, not so much the math end of this. So Mr. Cadella, take it easy, but we're going to overgeneralize what this number means to us right now. And when you guys work with your mentors or take AP Stats, you'll kind of see where I'm overgeneralizing this. But for the sake of understanding the science of this, let's simplify this to this. R-squared value shows us how well our data fits a best fit line. And what this is saying is it's 98.6% good. So that 0.986 is really like a percentage, you could think of it as. And what that kind of means is 98.6% of the time, if we were to ask someone on a scale of 1 to 5, how much do you like bananas? And we looked at our graph and said, okay, they answered a 4. We look at our graph, we go up, we see it's a little over 100. You go, do you eat a little over 100 bananas a year? And they're like, oh my God, how did you know? Great, 98.6% of the time, we would be right. That seemed pretty high? Yeah. The best would be 100% of the time we would be right. That's an R-squared of 1. An R-squared of 1 is the highest R-squared that we see, 0 being the lowest. So with an R-squared of 1, we would know 100% of the time we're correct, and we've definitely found a relationship. And an R-squared of 0.986 is also very high, and this would mean that yes, there is a relationship, a direct relationship between the enjoyment of bananas and bananas eaten based on our data. So let's look at a more real data set here. This is some real data that I found on the internet randomly. Temperature and cricket chirps. So this is kind of an interesting one. As the temperature gets warmer outside during the summer, do crickets chirp more per hour? Kind of interesting. So here you'll notice we collected data not in order, right? So it's hard to see if there is a relationship or not. We don't have to put things in order. We could simply highlight our data set, again, including those titles on top, and make a graph. So I want you guys to pause the video and tell me whether or not there's a relationship. So go, do it now. You did it? All right. So let's see if we can do it the same. I'm gonna make my graph. Boom, there she is. My axes are labeled properly. I have temperature on the x-axis, cricket chirps on the y. That makes sense because I think I want to see if temperature determines how many times the crickets will chirp. I don't kind of like the bounds of this graph. It looks like all of my dots are in the top, some are getting cut off. What I'm going to do is I'm going to go to the horizontal axis pull down, and I'm going to set minimums and maximums here. So for my horizontal axis, I'm going to say, all right, maybe let's make 60 degrees our minimum, and our maximum maybe like 92. So then this way our data is spread out maybe a little bit more. And then I'm going to do the same on the vertical axis as well. So on the vertical axis, I'm going to say, looks like everything's towards the top. So I still like to have 0 cricket chirps be the minimum. That kind of makes logical sense, but maybe I'll go like 22 on the y-axis so we can kind of see all the data. Now, looking at this, guys, does it look like there's an increase as temperature goes up? It kind of does, right? If I look at it, it seems like, hey, there's a bit of an increase here, right? The dots are higher up on this end than they are on this end, aren't they? So let's see if this is an actual valid analysis we can make. So let's get Series. Click on Series, go down, I'm gonna hit a trend line. I got a linear trend line, looks to go through the data. It does show an increasing trend line. Okay, looking good. But now let's click the R-squared value. So we get an R-squared of 0.697. So again, oversimplifying this, 69.7% of the time, so roughly 70% of the time, if we were to measure the temperature, we'd be able to predict cricket chirps per hour. Is that good enough? Could we say there's a relationship here? I don't know, man. 30% is, getting it wrong 30% of the time is not so good. So there's kind of a cutoff number that we use in science. That number is 0.9 for an R-squared value. Above 0.9 means, yeah, this is a pretty solid relationship, but below 0.9 means not a good relationship. So we really want to be confident 90% of the time to truly say, hey, these two things are related to one another. Being, 70% of the time confident, I mean, at this point, there's a pretty decent chance that if we were to measure this, it would not fit the line at all. Now, maybe if we collected some more data, we could see some differences. That might be interesting to look at. But with the data that we have here, we would say there is no relationship. So hopefully this helped you guys kind of understand how to make a graph and how to see whether or not there is a relationship between two variables in an experiment. All right, so now let's get to the actual class challenge part of this. Let's rock and roll. All right, guys, around this time of year, do kind of the same thing. I'm writing letters of recommendation, and I also have ADHD. So when I write these letters of recommendation, I like to have something playing on another computer screen as I'm writing. Now, the thing that I'm playing on this other computer screen cannot be actually entertaining. Otherwise, I just won't work on, writing letters of recommendation for students. But if it's too boring, then I'll get really bored of writing letters of recommendation. I have to do so many every year, so it gets really tiring after a while. So what I need is that something on one screen that keeps me just engaged enough that I'm not going to lose my focus. And what happened is I put on something that I thought would be so boring, but instead it sucked me in. And so I put on a recording of a stream of a guy who builds custom computer keyboards while listening to jazz music. Let's take a look at a little clip from the stream right now. Seems pretty loud. Turn this down for you guys. So as you can see, this guy is opening a box of computer parts with jazz music going on. Really thrilling stuff. Let's jump ahead and watch him unpack some things.
Should I pull out my other Hamon desk mat? You guys want to see a comparison? Nefarious Trav, thank you so much for the Twitch Prime sub.
It's a little weird. It's a little weird. But don't worry, it gets weirder.
You guys ready?
What he's opening up right now is a bag of key switches. So on like an old school keyboard, like the one you see on the top of his screen, there are these little mechanical switches inside that, you know, when you press it down, tells the computer that you pushed a key. Most modern keyboards are a lot smaller than this right now, but he's opening a bag of special keys called Novel Keys Cream switches. And they're named creams because they are very, very smooth as you press them. So he's gonna open this bag up of computer keyboard switches.
I think this is the most number of creams I've ever seen in a single bag. This is not a good smell. It's not a good smell, but like you guys know those like something about musky smells.
No,
It's not good.
no, no, it's
But you
not.
also come back
No.
for it.
No, we
for
don't.
some odd reason.
No, we don't. He's gonna do it again.
It's one of those.
So, as you can see, I clearly had to stop everything that I was doing and watch the remainder of this 2 hour and 45-minute stream about building a keyboard. And we're just going to click through real quick, but it's kind of crazy. You could see he's individually lubricating every single one of these little switches for this keyboard. And then as we go, you can see him starting to put the pieces together for the keyboard. This is like a $3,000 keyboard that he's building, which is just bananas that keyboards are that expensive. And he starts putting everything together, and then he's going to test it by typing as fast as he can. So we'll watch an example of that here. Let's see. So now if you take a look at the Twitch chat right above my head, you'll see everybody's guessing random numbers. So the numbers that they're guessing is how many words per minute he's about to type on this keyboard. So we're gonna see how fast he types. And I think he has one of those things where if like you get it right, you win a giveaway or something like that. So that's why everybody's guessing. It's also sad that there is that many people actively watching this right now.
These away. How will this sound? Do you guys want angle 1 or angle 2? 1, 2.
Oh my God. Skip ahead. So as you can see, this dude is just flying through the keys right now. Typing super fast. Keyboard sounds incredible, as it should when it costs like almost $3,000. So there he goes. Let's see what speed he gets at the end of this little test. Oh, making a few mistakes. Oh man. Is he gonna finish? That space bar sounds incredible. You just hear that every time he hits it. Oh no, I made a mistake there. Let's see what he's at. Oh, he's flying now. He's in the groove. This is ridiculous.
Ooh! 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 136.
So there you go. He just typed 136 words per minute, which is very, very fast. So why in the world am I showing this? Because you guys are going to conduct an experiment for me. Because I thought about this and I was like, you know what? I wonder if my students are doing a good job on their review of literatures. And my thought is this: if they're not, you guys are not doing a good job in your review of literature. You're likely just sitting down and just typing, right? You're not really editing and crafting each sentence. You're just typing, right? You just get in that flow where you just type a paper. Would the speed at which you type be related to the length of your review of literature? So, what I would like you guys to do as a class is design an experiment. And I want you to think about a few things here as you design this experiment. I want you to measure the speed at which everyone in this class types and match that to the length of their reviews of literature. So what I want to do real fast is bring up a little page here so we can kind of get this organized. All right, so first we need to get our typing speed. So as we just saw, we need to get this value in the units of words per minute. And how you get that, I want you guys to decide as a class. And it's important that you decide as a class, right? So I would love if you guys could have a class conversation and really talk about how you're going to measure this in a way that's applicable for your review of literature and the way that you write it, as well as what is the industry standard for people that spend a lot of time typing. Hint, you might have just seen it. So you need to get your typing speed, and I want you to make sure that it is applicable. So whatever method you use is applicable to your review of literature, and it's also a standard, right? There is a standard way of measuring this that exists, right? We don't want to deviate from that. We don't want to reinvent the wheel. We want to use a validated method. Okay. Next thing we need is the length of our ROL. So we need to get our length of our ROL. When you guys do this, I want you again to talk as a class and think about how would you measure this? This there's no standard for. And again, how are you going to measure this applicable to your ROL? So, for example, works cited, are you going to count that? Right? Are you going to count works cited? Are you going to count title page? That is up to you guys. I'm not saying that you shouldn't do these things or you should do these things. I want you guys to have that discussion and come up with how you think you should do it. And then I also want you to be thinking about the method for doing this, right? There's a lot of uniqueness with writing a review of literature. There's a lot of words that are really long in your reviews of literature. Should that be counted for more? What do you think? Again, I want you guys to come up with a standardized way of doing this. Then what I would like you to do is ask your teacher who's in class with you right now, so that's either Mr. Pena or Mr. Valtakis, to post your class's Google form on Classroom. So when you guys go to make this Google form, one person in the class can set up the Google form where everybody in the class is going to be able to enter their typing speed and enter the length of their review of literature. Okay? And I want you guys to create a Google form for that. Add me as a collaborator on that Google form and post it on Google Classroom. Once you post it on Google Classroom, I'll go in and take a look at it, see what you guys are doing, maybe provide some feedback in the comments on Google Classroom. And after that, what I want you to do is then take that collected data and share it with everyone in the class. And I want everyone in the class to determine, is there a relationship between typing speed and the lengths of your review of literatures? So with that, I'm going to leave you guys with a bunch of work to do. This will be due on Google Classroom, though you'll see a post there in terms of what you need to do for this assignment. And after that's done, we'll jump into our next video. So I'll see you guys then. Later.